Hello, welcome back. First, I want to introduce this project information. This is the data that we'll be using throughout this chapter to introduce you to the various capital budgeting methods. So I am going to ask you to pause the video now and write down this information or print out this slide so you have all this information in front of you. So here is, we jump right to the bottom line of the project. So we assume that you have done the analysis on the project. You look at the revenue, you look at the cost, you look at the investments. And here are the bottom lines. If you invest in a particular project, you expect that this project is going to cost you $165,000. So that's why in year zero, which is the beginning of the project, you have a negative cash flow, a cash outflow. So that is the cost of the project. And then based on your estimate, you expect that this project is going to generate $63,120 in year one, $70,800 in year two, and $91,080 in year three. So these are your cash flow forecasts in this project. We're going to look into how to come up with this cash flow in another module. So in here, we assume that either another team has done the analysis and forecasted it and forwarded this information to you, or you had done this analysis ahead of time, and this is what you have come to. Another thing that is important is to look at the opportunity cost for this project. So the required return or the discount rate that you'll be using for this project is 12%. So what that means is if you don't invest in this particular project, you could invest in a similar project with similar risk, and you can earn a 12% return. So this is the information that we'll be using in introducing all the capital budgeting methods. The first method we're going to introduce is the net present value rule. Right here, I want to emphasize that the net present value rule that we introduce in the context of capital budgeting is different from the NPV function on your calculator or on Excel. They are related because the NPV function on your calculator and the NPV function in Excel are designed primarily to apply this rule. However, the concept is like it is not embedded in the computer function or the calculator function. So the principle behind the net present value method in capital budgeting is that we compare the total value, the total present value of future cash flow versus the initial cost. So the term future cash flow here has special meaning. So future means that it starts in year one and on. So year zero is today, starting in year one is the future. So we are focusing on future cash flow, and then we have to compute the present value of those future cash flow. So that's the first step. And then we subtract from it or compare it to the initial cost. So initial means today, and today means year zero. So we actually have already learned how to do those things when we study the time value of money. We're applying the time value of money tools to the net present value method. So before we look at the criteria, the acceptance criteria, let's first take a look at how we will compute the net present value for a project. So here is the project information that we have. So remember that to compute the net present value, we need two parts. First, we need the present value of future cash flow. So present value of future cash flow means cash flow from year one and on. So we need to find the present value of these three cash flow. And you can use any method to solve this problem. I'm going to use the financial calculator, and I'm going to use the cash flow register. So when we are computing the present value of future cash flow, I need to look at what cash flow am I evaluating. So with the calculator, we're going to use the cash flow function. So we start with cash flow. And remember that we want to clear the register. So we will go clear work, which is a second function. So we do clear work. When we are computing the present value of future cash flow, we start with year one. So we will not put any information into year zero. And year one, we have $63,120. And remember, we have to press enter. We only received that cash flow once, So we'll move on to cash flow in year 2, which is $70,800. Again, we need to press enter. And then in year 3 is $91,080. So now, that did not take place, so we'll have to enter that again. So you will see, you can also scroll back to make sure you have entered all the information correctly, and that's a good idea. Once you have entered all the cash flow, we'll go to the NPV register, and our interest rate in this case is 12%. So we'll do 12. Again, press enter. We'll scroll down one. We want to compute the NPV, so we'll press compute. Now, since we only enter the cash flow starting from year 1, the answer we get is the present value of future cash flow. So we have the present value of future cash flow, and the initial cost. Remember, the initial cost is the amount in year 0. In year 0, the project cost $165,000. So we have the value that we need to finish computing net present value. So we have $177,627, which is the first part, total present value of future cash flow. Subtract from it our initial cost of $165,000, and we have a net present value of $12,627.42. Once we have our answer, then the question is, what does this answer tell us? So it depends on whether or not the projects we are evaluating is a independent project or whether it's a mutually exclusive project. If it's an independent project, all we need is a minimum cutoff. So now let's take a look at what these numbers represent. This is the value of the project. This is the cost of the project. So it's clear in here that the value is greater than the cost. So when the value is greater than the cost, the answer we get, the net present value, will be greater than or equal to 0. So in this case, the decision rule is that we'll accept the project if the net present value is greater than or equal to 0, because that project has a value greater than the cost. And by accepting this project, we are adding to the value of the firm. There's one subtlety that I want to emphasize. Notice that we say that it's a good idea to accept the project even if the net present value is simply 0. In fact, if the market is sufficient, you expect that most projects will have a net present value of 0. Because when you have a project that has a net present value of 0, you are earning exactly the required return. So the way that you interpret this number, the $12,627, is that this project you're investing in generates a 12% return, and it provides you an additional $12,627 in value over and above the 12%. So if you have a competitive market, you expect that most projects will earn about the same return, and therefore you earn the 12%, resulting in a net present value of 0. If you were evaluating mutually exclusive projects, then you have to compute the net present value for each of those projects and then choose the one that has the highest net present value. The next method I want to introduce is the Profitability Index rule. The Profitability Index is very similar to the net present value rule. Remember that the net present value rule, we subtract the initial cost, the initial investment from the present value of future cash flow. When you compute the profitability index, we divide the two. So instead of the difference, we are computing the ratio. Also notice that I intentionally use the term cost and investment interchangeably. So the idea is that in year 0, you are investing in the project. So the cost that you incur in starting the project is a form of investment. So I'm going to go ahead and use the numbers that we had just calculated because we did the same calculation before. So remember, if you were going to compute the profitability index, you need to first compute the present value of future cash flow. That's step one. And then you will do the division. In this example, since we already did the calculation, as I said, I'll simply use the value. From the last calculation, we remember that the present value of future cash flow is $177,627.42. And then we'll divide that by the initial cost. So one topic that sometimes students get confused is the cash flow in year zero, 165,000, a positive number or a negative number? And here's where economic sense trumps blind mathematics, I would call that. Because if you apply common sense, you understand that this project costs $165,000 to start. So if you are trying to figure out is the value greater than the cost, you're going to subtract it. If you are trying to compute a ratio, again, how large is the value relative to the cost, then it only makes sense if you use the $165,000 by itself. So again, this is a context issue, not a mathematical issue. So this is where strict mathematical formula can cause unnecessary confusion. So take one step back and ask yourself, what information am I trying to get to by doing this calculation? So I encourage you to pause the video if you're not sure where the numbers come from. Make sure you understand where the $177,627,000 come from and where the $165,000 come from. Now you may want to ask, well, what do I do with this number? What does it tell us? So take a look, again, pause this video and ask, when will a project be a good idea? So basically, welcome back. Basically, a project is a good idea if the value you generate is greater than the cost, right? So you want the numerator to be greater than the denominator. So the exception of this rule will be that you accept a project if the profitability index is greater than or equal to 1. So in this case, we'll decide that this is a good project because it generates value that is greater than the cost for this company. So the profitability index rule is quite similar to the net present value rule. And in fact, for projects that are independent, the two rules will always lead to the same conclusion, because if the difference is greater than 0, the ratio will be greater than 1. However, when we are dealing with mutually exclusive projects, we'll have to compute the profitability index for all the projects, and then we'll select the one that has the highest profitability index. And in that scenario, the two may or may not lead to the same conclusion. So in fact, this is one of the disadvantages of the profitability rule. The reason why is because of scale problem. So you could have a project that has a very high ratio, which is the profitability index. However, if the project is a small scale project, a high ratio will still generate a limited size in value, whereas the net present value rule measures the magnitude of the value that is generated by a project. So the bottom line is, if you have mutually exclusive projects, then you want to go with the net present value rule. There are qualitative reasons that you may want to take into account, but if you are looking at, again, this is mutually exclusive project, so that means if you go with the smaller project, you have to give up the bigger project. So this is not, when they are independent, then you can accept as many projects as you want. The next method that I'm going to introduce is the internal rate of return method. This is by far the most common alternative method to the net present value method. The reason for that is because this method is very intuitive and it's easy to explain. when we try to explain the concept of net present value or profitability index, we have to include the concept of opportunity cost, meaning the required rate of return, as well as the additional value that is created by the project. And that is two or three concepts all combined into one. Whereas the internal rate of return simply says this is the return we get on this investment, period. So that's a very attractive feature of the internal rate of return. The other advantage of the internal rate of return method is that it's based solely on the discount on the estimated future cash flow. So and it's a very self-contained way to compute the return. So let's take a look at how do we compute the internal rate of return. It is defined as the discount rate that sets the net present value to zero. So I'm going to hold off on exactly what that means in a minute. I'm going to show the calculation method first. So here are the cash flows for our project again. So remember that the internal rate of return includes all the project's cash flow. So that means cash flow starting in year zero all the way through the end of the project. And that's the only information you need to compute the internal rate of return. So we're going to enter these cash flows into the calculator now. Remember, we start with the cash flow, and then we want to clear the register in our calculator. Since we include all the cash flows, we have to include cash flows starting in year zero. And we need to enter $165,000 as an outflow. To do that, we'll have to enter the information in this sequence. So we start with the value of $150,000. We need to change the sign to negative, and then we can enter it. The rest of the information is the same as what we have done before. So I'll just go ahead and do that. So remember to press enter after each cash flow. It's a good habit to always scroll through your cash flow to make sure that you have entered everything correctly. So we go back to cash flow in year 0, 1, 2, and 3 to confirm that we have entered the information correctly. Next, we're going to press IRR and press compute. That is your IRR. So the internal rate of return for this project is 16%. Now, how do we use the information we just computed? Is 16% good enough? Is that a high enough return, or is that too low? To answer that question, we have to then look at another factor, and that is the required return for projects of similar risk. So this is typically the discount rate that you will use to compute net present value. So now this is our benchmark. This is what you can earn on other projects of similar risk if you don't go ahead with the one that you're considering. So since we can get 16% investing in this project, whereas other options will only give us 12%, the answer is relatively simple. We would want to take the project that is giving us 16%. So again, we want to understand the economic reasoning for why we accept or reject a project rather than memorizing the rule. But in this case, if you're working with independent projects, the acceptance criteria is that you accept a project as long as the internal rate of return is greater than the required return that you would use in computing net present value, because this required return represents the opportunity cost that you're giving up in other projects. Now, if you are working with mutually exclusive projects, then you have to rank those projects, and you'll rank them by the internal rate of return. So we said a lot of good things about the internal rate of return, but it does have some disadvantages. One of the major disadvantages of the internal rate of return is that there may be more than one internal rate of return when the cash flow changes signs more than once. So sometimes you may hear this referred to as a non-normal cash flow or an abnormal cash flow or irregular cash flow. The reason why we use those terms is because in a typical project, we have a cash outflow in year 0. You spend all your money investing in the project, and then in the future, you will generate positive cash flows. But there are occasionally you may be looking at projects that may have a huge investment in the beginning, have some cash inflow for a few years, and then another cash outflow for another round investment in the future. So if you have one of those projects, then you may have more than one internal rate of return. We're going to look at these disadvantages more in our next lecture. But that's one of the major reasons why internal rate of return may not be an appropriate rule to use. So whenever you see a project whose cash flow changes sign more than once, it does not mean you cannot use the internal rate of return, but you have to check first. So you have to check whether or not that sale of cash flow will lead to multiple IRR. If they do, then this is not, then you cannot use this method. Another disadvantage of the internal rate of return method is the case when you have two mutually exclusive projects and you have to rank them. In that case, you may encounter a situation where the ranking based on the internal rate of return may be different from the ranking based on the net present value method. And then you have two methods giving you two different signals, and you have to decide which method to go with. So we will end this video here. In the next video, we're going to delve more in depth into the relationship between internal rate of return and the net present value method, and look at the challenges that is presented by the internal rate of return method.